Okay, so I want to find the average rate of change. Can somebody give me the equation for the average rate of change for any function? Okay, now Peter, I'm going to let you take this one out for the whole rest of this question. Peter, go.
Okay, so m
Good, and this is something you will need to commit to memory in this class, and this is also related to what we're going to be doing today. So that's something that you will need to use. All right. So in this case, what are my x2s and what are my x4s? Roland, go ahead.
I said my x2 was the f2.
Okay.
And my x1 was my f3.
Good. And you could have done it the other way too. If you remember back from grade 9, whether you calculate your slope from here to here, because that's basically defining as the slope of the line. Whether you go from here to here or here to here, it's still going to give you the same slope. Okay, on the side, being your next board, I'm going to find out what f of 2 is. Can somebody tell me how to find f of 2 in English? And then give me the calculator work, please. Somebody new. Haley, go ahead, please. Very good. So I'm going to write that in there. Okay, Bailey, we able to get a number for that, please? Okay, 24. Not that I don't trust you. Can I get one other person to raise their hand? That's right. Okay, good. Okay, can I do trust you, so Bailey. Can somebody tell me how to do f of 3, please? Somebody else. Go ahead.
It's the same equation, you put 3 over
Right on. As far as showing your work on a test, you don't need to do this. I am okay with saying you got it from your calculator what f of 2 and what f of 3 is. Okay, I'm okay with that. I'm just showing this for your notes, so when you're looking to study before your final exam, you can, know where all this came from. Cal, did you get an answer for f of 3?
Yeah, negative 185.
185, you said? Yeah. And someone else from that, I hope. Good. Okay, so now all we're going to do is we're just going to sub it in. Remember, I taught this lesson to my grade 11s today. F of 2, remember, is the y value when x equals 2. That's what that equals. Okay, so on the graph, there's a point at 2, negative 24 for this graph. There's another point on the graph at 3, negative 185. Okay, so what I'm going to do then, I'm going to say this is equal to negative 24 minus negative 185 all over negative 1. What was it, 164? No, negative 164. Is that right?
I got negative 161. Same.
All this happens for Sadler because he can't add. Okay, I'm sorry about that. Okay, negative 161. What does that mean in English here now? Please tell me what that means, because this is the important part. What does that actually mean? Boston, go.
That's the average rate of change.
Yeah, between
down one.
Right on. Okay, the average rate of change from 2 to 3, you're going to be dropping. So if I was drawing this graph, which I'm not, okay, the graph is probably going to look something like this. Okay, that's what it's going to look like. So this is going to be f of 2 is up here, f of 3 is going to be way down here like that. Okay, it's going to look something like that. It's not going to be a slope of negative 161 all the way across, but the average slope, the average rate of change is going to be like that.
Would that be like a future straight line?
Right on. Yeah, exactly. Sorry, thank you. So it would look something like this, except for that's a straight line that's going through both the points, of course. Okay. But you get the idea, though, right? Like you're just one step over your axis, and you're going down on negative 161. Okay. Are we sort of okay on that before I get to 7? Because 7, they threw a nice little twist at you, which made me very happy. That's why I signed it. Okay. I apologize once again for 6A with that messy polynomial graph. I apologize. I just glanced at it. I said, just said average rate of change average. That's what I was looking at. I missed the A part. I apologize about that. 7, though, I didn't miss anything. This is intended to be discrete. So this is page 62. Okay, so this was a fun little question. Please put a star beside this one. I didn't actually put this on your assignment, but since this one has been asked in class, and I went through this with a few people today, and I said, wow, that's a really awesome question, okay? This one you could see on your test, hypothetically, okay? And if not on your test, definitely in the final exam, okay? So, I can't believe we're really in February already, but we are. This says, actually this question I gave in calculus, this is exact calculus, the result of calculus. As a large snowball melts, its size changes. The volume is given by 4/3 pi r cubed. It says the surface area is equal to 4 pi r squared. Also, it says here that as well. Can somebody please remember back from the first day of the out for this first most of this question, okay? Anyone recall what that means, that 0-30 thing from the beginning of the year? Yeah, go ahead.
It can be anywhere from 0 to 30.
Yeah, no, this is equal to though, right? So it's less than or equal to, greater than or equal to 30, and less than or equal to 30 and greater than or equal to 0. Okay, so that's the other way to do domain and range detection. So why would you need a domain and range on the volume of a snowball? Yeah, go ahead.
Because if it's melting, it can't be over 30, and it can't be less than 0.
Yeah, maybe sort of. Okay, definitely it can't be less than 0. Probably for this question, the snowball started at 30 centimeters. Okay, right? So it can't get bigger than that. Okay, so if it's melting, you make a big snowball like this. That's how big it is. Okay, and that's the starting point. So that would be the 30 for the radius. Letter A says, what type of polynomial function, okay, does this represent? Which one are we doing here? Each formula. Okay, so I do the volume. What is the volume? What type of function is that? Go ahead. Yeah, this is a positive cubic function. Positive cubic odd. And using a rough sketch, how do you graph a positive odd function? I hope you know at this stage in the game. Albert. And that's all you need to do, okay? If you want to plot points, go ahead, okay? It's going to be something like this. Now, we could probably do a few other things for this, okay, for my volume. What points what might it make sense to put into this? You don't need them, but what could probably be useful here, Matt?
0, 0, 1, negative 1, 1.
Not in this case. A 0, 0 definitely. But why does, I probably don't want to need 1 negative. Probably not going to make sense. Right?
Why don't you put in 30?
30 would make sense, okay? Why would 30 probably be one that would be useful here? Why is 30 probably another good one to use? Yeah, right? Okay, that's how it's going to be, that's going to be the other endpoint. So I'm probably just for fun, you don't have to do this. So I'm going to say volume is equal to 4/3 pi times 30 cubed. Somebody give me a number for that? Somebody big. 30 cubed is what, 27,000?
It's 113,097.
Okay, that's a big number, okay? 11307. You don't have to, that's what I'm saying, like a perfect graph you're not going to get, but all we're saying is that, now looking at that graph, that's the volume. Why does it make sense that that's cubic? If you look at the slope, how does the slope change for this? What happens to the slope? Think about how the slope's going to go. Yeah, so we're starting with the big slopes. When you have the volume, it's going to be decreasing quickly as the radius changes, and then as you get towards 0, it's going to be slowing down. All right, and that's what we'll get to more of that in calculus. I don't want to freak you with that yet, but that's on top of that every day probably in calculus. If you didn't want to do that 30, 11,000, you didn't need to, or 113,000, you didn't need to. But the idea, at least I wanted to see that's a positive odd function. You should at least give me this to see how it's going to go. Okay. State the domain and range. What's the domain and range for this? Well, it looks like anything. Okay. If we're going to use this, we're going to say my domain is 0 to 30. My range is 0 to 11,3097. Okay. Yeah.
So, like it just states in the book that the surface areas, that's the restriction on like the domain, like the restriction for the surface area.
Yeah.
So can you just add that to volume too?
Yeah, it says here the volume, where the r is the radius, the centimeters. Because the variable r is applied to both equations, I'm assuming that I would infer that that would be for both of them, right? For volume and surface area. Okay, anything else I keep trucking here? Hope? Let's keep going. Letter B says determine the average rate of change. Do you want me to do this? C and D, they're probably the tricky ones. For fun, I'm just going to use the volume equation. I'm going to ignore the surface area. So I'm going to say volume equals 4/3 pi r squared. It's pi r cubed is the same thing. So for the first one, it says from 30 centimeters to 25 centimeters. I want the average rate of change. Okay, if I'm using that equation, someone there's not raised their hand today, please be brave and tell me how to find that. I'll be happy. I'll take you anyway. Go ahead. Very good. So M is going to be V of 30 minus V of 25 all over 30 minus 25. So that's just what average rate of change is, right? And that's what we were doing yesterday. Right? Now, this is where things get tricky, and this question bothered me in calculus, and it's going to bother at least one person at lunch today, okay? If you're going from 30 to 25, all right, will the volume be increasing or decreasing? Decreasing, right? And that's what it should be. The problem is because the slope is still increasing. It's probably going to be a positive answer here, all right? Because this isn't, I don't really know how to explain it. It's going to be a positive answer for this because the rate of change from 25 to 30 is going to be increasing. We'll see how it goes for that works out. Okay, can somebody give me just a final answer? I don't want to work so you guys can do the calculator work yourself. You get an answer for this?
It's 9,529.5.
9,529.5. And I'm assuming more decimals there. Okay, what they also want you to do then from 25 to 20, what they're trying to show you. What they're trying to show you for this is that probably the slope is decreasing. So the slope was from 25 to 30, it's going to be high. I'm guessing, I haven't done this question, but probably it's going to be 4,000 or 5,000. 6,000? Okay, what's up for that? 6,387.9. Okay. And what the point they're trying to make here is, if you go from 25 to 30, the slope's going to be very high. If you go from 20 to 25, the slope's going to be less. That's all we're saying for that. Okay, that's the logic that they're trying to do. Are we okay on sort of what happened before I keep moving here? So this is just average rate of change. So a lot of blank faces. I don't know if it's because it's the end of the day. I don't know if you're giving up on life. Jesse, don't give up on life. You can do this. I'm not kidding. You can do this, Jesse. If you get stuck, knock on the brother's door. I would love it if you were to do that. Actually, that would totally make my whole life. No, it would. As long as I'm not there, then I'd be like, oh no, Jess. No, I'm just joking. Okay. Are we okay though with average rate of change here? That's the basic plan from yesterday's lesson. Okay, because we're getting to instantaneous today. Next is letter C. Actually, I'm going to skip C. I'm going to go to D. Because C is surface area. I'm going to stick with volume here, okay? So letter D says, and this is the new part, it says, determine the average rate of change in volume when the volume decreases from 1675. Okay, and this is a lovely question to all to think backwards, right? Okay, what did they actually give you in this question? What did they give you in this question? Go ahead.
The y value.
Yeah, they gave you the y values. You just got to run around and solve for x. What they told us was f of x2, or v of x2 technically, sorry. So v of x2 is equal to 1675.52. They told us that v of x1 is equal to 942.48. That's what they told us. Okay, so what we have to do then is we have our numerator, we just have to solve the denominator. That is the exact opposite of what happened here. So here, they gave us our two x values. We just sub them in to get the y to calculate it out. In this question, we get this number, we get this number, we just have to solve for the bottom. Is that sort of making sense before I do it? Okay. So on the top, then I got to get my equation 4/3 pi r cubed. So what I know then is that 4/3 pi r cubed is equal to 11675.52. R cubed is equal to 3 times 1675.52 all over 4 pi. R is equal to the cube root of 1. This is why you guys have calculators and not me. Okay, so that's just me showing off my math skills is what that is. Alright, so I just rearranged everything. So I multiplied by 3 to get rid of the fraction, divided by 4 and divided by pi, and then I took the cube root. And when I say me, I mean Alana did that. Alana, what did it for an answer, please? That one. 7.37 is what? Okay, so basically what I found here, that went with this one. So therefore x2 equals 7.37. Right, so you see what we did? We just solved backwards. That's all we did there. Right. Brian, are you okay with this? Lovely. So I'm going to do the same thing again in blue. I'm going to say 4/3 pi r cubed equals 942.48. R cubed equals 3 942.48 all over 4 pi. R equals the cube root of all that. 6.1, you said? 6.1. Okay, now what you probably should be doing if you get this on your test is using every single decimal known to your calculator on this, okay? If it works out nicely, I think the previous one had like 14.9999999, so we went to 15 and 10, and worked out nicely, but this one that was messy. I will try my best not to trick you up on decimals, but if you get a question like this, be as accurate as possible. Totally, you're feeling okay with what I'm doing here? Okay? It's just backwards, just a twist, that's all this is again. So my slope then is going to be v of x2 minus v of x1 all over x2 minus x1, which equals 1675.52 minus 942.48 all over 7.37 minus 6.1. Alana, tell me again, get an answer for that, please.
577.2.
And this is what the textbook is. This is the one that the textbook is backwards with the negative in there for it. I worked this out in the calculus class too, and I couldn't find a way to make it negative. It says it's decreasing, so it's that. Peter, go ahead.
So on a test, like if you get what's your range for like a different degree? Like I got 72.
Yeah, what I would expect you to do on your test, if you get to a decimal, is if you have a fraction button, change to a fraction, so you can be as exact as possible. For something like this, and I don't hear this been in my 3U, remember I keep talking about it, just think of it like that. Okay, right, we're going to leave every decimal humanly possible that your calculator writes out. Okay, for this. I will try my best, do enough to worry about on your first test, that you shouldn't have to deal with too many decimals, like more than 1 or 2. But let's say the cube root of that is probably 7.3684392949. Okay, if it's something like that, I want you to be as exact as possible. And I know that the ways you use teach physics had a problem with this, it's to use sig figs. If anybody's in physics, and that's fine, but just use what your calculator says for that as best you can. So, I'm not here to trip you up on that, like as long as you can sort of make out what you've done. Okay, did that somewhat help? I hope a little bit on that. Jesse, did that help a little bit? You just say the other is the opposite, right? Like if you get the opposite way of work from the first time. Okay, you ready to move on to today? Yes? Okay. today is gonna be an awesome lesson. I'm gonna give you a second to, okay.